Question 2. Which of the following statements about a polynomial function is false? A. A polynomial function of degree n has at most n turning points. This could be false. Think about it. B. A polynomial function of even degree may have no zeros. Well, that could be true. A polynomial function of odd degree may have at least one zero. And D is, a polynomial function of degree n may have up to n distinct zeros. Okay, now in this kind of a question, it's better to draw or sketch a function and see for yourself. The simplest of the functions could be like quadratic function, right? So why don't we just draw and check? So if you have a quadratic function, so what are the possibilities? A polynomial function of degree n has at most n turning points. So quadratic function is kind of degree 2, right? So how many turning points does it have? Does it have 2 turning points? No, it has only 1 turning point. So the first statement is wrong. Do you see that? So a polynomial function of degree n has at the most n minus 1 turning points, right? That is the right statement. Second says, a polynomial function of even degree may have no zeros. That is true, because let's say this, if I do it like this, it has no zeros, right? Here it has 1 zero. A polynomial function of odd degree may have at least 1 zero. That is true. Odd degree polynomials will actually go from quadrant 3, they go to the opposite ends, right? And if you have to go from quadrant 3 to quadrant 1, you have to cross the line, and thereby you will have at least 1 zero. Well, if the leading coefficient is negative, then they will go from 2 to 1, right? Even then, they have to cross the line. So odd degree function will always have at least 1 zero. Even degree function may not have, correct? For example, think about this, right? May not have. But here, any function will have. Do you see that? They have to cross the line because they are going into opposite coordinates. Okay? So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Even function will go from quadrant 2 to 1 or from 3 to 4 depending on the leading coefficient. If leading coefficient is positive, it goes from 2 to 1. If leading coefficient is negative, it goes from 3 to 4, and it can do that without crossing the line, x-intercept. It can go like this, right? Do you see? That means no zero. But for an odd degree polynomial, if leading coefficient is positive, it goes from quadrant 3 to 1. It has to cross x-axis. Thereby, there will be at least 1 zero. And if the leading coefficient is negative, it goes from quadrant 2 to 4. Even then, it has to cross the x-axis, and there it will have an 0, which is an x-intercept, correct? Now, a polynomial function of odd degree may have at least 1 zero, so that is true. A polynomial function of degree n may have up to n distinct roots. So up to n distinct roots means what? Distinct roots means x-intercepts, right? The real x-intercepts. So let's say it like this, right? And taking our here, x squared is a good option, right? A polynomial function of degree n, degree is 2, right? May have up to n. That means degree 2 has 2. Do you see? This is x squared. Degree is 2, and it has 2 distinct zeros, right? So up to 2, that is true. So all of the statements are true except for statement number A, which is a polynomial function of degree n has at most n turning points. Maximum number of turning points can be n minus 1. Okay, remember that. I hope you learn from this. Thank you.